SQA Higher Maths 2024, the official paper that you probably sat today. I'm going to go through the full solutions here in depth as much as I can and hopefully not make any mistakes. Let's get started straight away. SQA Higher Maths 2024, paper 1, question 1. A line passes through the point 0,4, makes an angle of 30 degrees with a positive direction of the x-axis. Determine the equation of the line. Well, that's nice and simple to start with. Gradient equals tan theta. And it is the positive direction, so it's just tan 30 degrees. And an exact value triangle will help with this, 60 and 30, 2, 1 and root 3. So tan 30 is opposite over adjacent, 1 over root 3. So now I've got the point on the y-axis, so I can just use y equals mx plus c, because I've got c is 4. Mx plus c, so y equals 1 over root 3 x plus 4. And we're done there for question 1. SQA Higher Maths 2024, paper 1, question 2. A sequence is defined by the recurrence relationship. un plus 1 is a fifth, un plus 12, and u1 is 20. Calculate the value of u2. Okay, so u2 is a fifth, u1 plus 12, but u1 is 20, so that's a fifth times 20 plus 12. A fifth of 20 is 4. 4 plus 12 then is 16. And we're done there. Part B, I. Why does it approach a limit as n goes to infinity? Because minus 1 is less than a fifth, which is less than 1, therefore the limit exists. Part 2, calculate this limit. Well, I use b over 1 minus a. So that is a and that is b. So that's 12 over 1 minus a fifth. That's 12 over 4 fifths. That's 12 times the reciprocal of 5 quarters. 12 divided by 4 is 3 times 5 equals 15. And we're done there. SQA Higher Maths 2024, paper 1, question 3. Y is 5x squared plus 3 to the 7. Find the y by dx. So this is the chain rule. So dy by dx equals, I'll take the 7 down, leave the function alone, 5x squared plus 3, and take 1 away for power, that's 6. And then it times by the bracket differentiated. So 5x squared becomes 10x. 3 is nothing. So then that just equals 7 times 10 is 70x. 5x squared plus 3 to the power of 6. And we're done there. SQA Higher Maths 2024, paper 1, question 4. P and Q have these coordinates, and R divides PQ in the ratio 2 to 3. Find the coordinates of R. So we've got a picture, I suppose, like this, and we've got a P down here and a Q up there. We've got R somewhere there, and the ratio is 2 to 3. So a quick and easy way to remember this is that 2 times that equals 3 times that. It's as simple as that. So we can just write 2 of RQ equals 3 PR. Now where does that come from? Well, it really comes from the fact that PR over RQ is 2/3. So you get there quite quick, and then you can expand and simplify. Now there is some tricks that some teachers teach where you do something about adding the coordinates and dividing. So you can say that at this stage, if you remember that trick, it's 2q plus 3p all over 5. That is a quick way, but I never do the quick way. Do maths properly. So we've got 2q minus r equals 3r minus p. So that's 2q minus 2r equals 3r minus 3p. And I want r, so I'll take r's over to this side to get 5r. And then the q and the p is going to be over here. And that's your 2 and 3. So you've got 2q plus 3p all over 5 equals r. Like again, you could have seen that from this kind of pattern, 2q, 3p over 5. So then we just put in what our numbers were. So q was minus 1, 11 and minus 8. So that's 2 minus 1, 11 minus 8 plus 3 minus 6, 1, 2 all over 5. So that gives me minus 2, 22 and minus 16 plus 3 6s is 18, 3 1s is 3 and 3 2s is 6 all over 5. Finally that gives me minus 18 minus 2 is minus 20, 22 plus 3 is 25, minus 16 plus 6 is minus 10, all that divided by 5 is final answer of -4, 5 and -2, and we're done there. So we can then say that that's R, so our coordinate R to answer the question is -4, 5 and -2, and we're done there. SQA Higher Maths 2024 Paper 1 Question 5. Function h is defined as h of x is 2x cubed minus 7. Find the inverse function h minus 1x. So I'll just start with y equals 2x cubed minus 7. Make x the subject. Y plus 7 is 2x cubed. Y plus 7 over 2 is x cubed then. So y plus 7 over 2 cube rooted equals x. But don't switch them back. So you just now straight away go into the inverse function. Inverse function of x equals now switch back. Cube root x plus 7 over 2. And we're done there. SQA Higher Maths 2024 Paper 1 Question 6. A right angle triangle in a diagram is such that sine p is 1 over root 5. P is between 0 and pi over 4. Then the value of sine 2p, cos 2p, and then sine 4p. So I've got a right angle triangle, so I will do Pythagoras to get one of the sides. So I've got root 5 squared minus 1 squared. That's 5 minus 1 is 4. So I've got root 4 is 2. So now, expanding this, that's 2 sine p cos p. So what's cos p? Cos p is opposite, adjacent of hypotenuse, 2 over root 5. And we already know sine p is 1 over root 5. So that's 2 times 1 over root 5 times 2 over root 5 times in the top, 2 times 1 times 2 is 4, times in the bottom, root 5 times root 5 is just 5. So you get 4/5. Cos 2p, well again, using the start exam paper, you can use any of the expansions you want, and the one I'm choosing to use is 2 cos squared p minus 1. But you'll get the same answer, I'm just using that because it's got a positive value. So that's 2, cos p is 2 over root 5, so I need to square that and then take away 1. So that's 2 times, 2 2's is 4, root 5 times root 5 is 5, minus 1. 2 4's is 8 over 5, minus 1, which is 5 over 5. That gives me 3 over 5, and we're done there. Hence, determine the value of sine 4p. Now, sine 4p is like sine 2p. If sine 2p is 2 sine p cos p, then this will be sine 2p cos 2p instead of pp, because it's 4p instead of 2p. So then I can just substitute in 2 sine 2p. Well, I know sine 2p is 4/5, so I can just write 4/5. And I know cos 2p is 3/5, so I can just write 3/5. So that gives me 2 4's is 8, 8 3's is 24, over 5 5's is 25. And we're done there. SQA Higher Maths 2024 Paper 1 Question 7. The line y equals 2x is a tangent to the circle x squared plus y squared minus 14x minus 8y plus 45. Find the coordinates of the point of contact. Well, finding the point of intersection means solving simultaneous equations, so I'm just going to sub it in. So I've got x squared plus y squared, which is 2x, minus 14x, minus 8y, so it's 8 times 2x, plus 45 equals 0. And we'll just solve that for x. So that's x squared plus 4x squared minus 14x minus 16x plus 45. That's 5x squared, and that's minus 30x, and that's 45. So 5 is a common factor. X squared minus 6x plus 9. Remember, this is a tangent, so if you get more than one answer, you've made a mistake here. So watch out. You could just complete the square, but I can see here that I can just factorise it half the term. That's 3 and 3 minus minus. Minus is a minus is a plus. That's plus 9. Minus 3 is minus 6. So you get x equals 3 as your x coordinate, and therefore y equals 2 times 3, 2x, which is 6. So your point of contact is 3, 6, and we're done there. SQA Higher Maths 2024 Paper 1 Question 8. The equation x squared plus m minus 4x plus 2m minus 3 has no real roots. Determine the range of values for m. So if it's got no real roots, that means that b squared minus 4ac must be less than 0. So a is equal to 1, b is m minus 4, and c is 2m minus 3. So we're just going to sub that in. So we've got m minus 4 squared minus 4 times 1 times 2m minus 3, and that's less than 0. So that's m squared minus 8m plus 16, take your time expanding. 4 times 1 is 4, times 2 is 8, so minus 8m. And then minus times a minus is a plus, so plus 12, less than 0. So that gives me m squared minus 16m, and then plus 28 is less than 0. So it's a quadratic inequality. So what we do with these is we look at the roots and draw a little graph. So the roots, we've got double brackets, m and m. And for the roots, we've got 14 and 2. Minus 14 minus 2 is minus 16. 14 2 is 28. So we get m equal 2 and m equal 14 as our roots. So we now draw a graph. Just a rough one. There's 14. There's 2. There's your quadratic. It was positive, yep. And we want it less than 0. So underneath here, that's between these two numbers. So our final answer is 2 is less than m is less than 14. And we're done there. SQA Higher Maths 2024, paper 1, question 9. Express log A5 plus log A80 minus 2 log A10 in the form log AK, where K is a positive number or integer. So rules of logs, log base A of 5 and 80 is plus, so 5 times 80. And then I'm dividing by something. Well, let's take that up to the top here. So let's do this one. That's log base A of 10 squared. So divide by 10 squared. So that gives me log base A. 5 eighths is 40, so that's 400. 10 tens is 100. That's log base A of 4. I'll have to leave it in that form, so we're done there. SQA Higher Maths 2024, paper 1, question 10. Show that x minus 1 is a factor of that, and then factorise it fully. We're just going to use synthetic division. 2, 3, minus 4, minus 3, 2. Put in 1 in, we get 2. 2 ones is 2, plus is 5. That's 5. 5 minus 4 is 1. That's 1. 1 minus 3 is minus 2. That's minus 2. And we get 0. We just say remainder 0. So x minus 1 is a factor. So now we have to factorise it fully. So for part B, we've now got x minus 1 times 2x cubed plus 5x squared plus x minus 2. So I need to find another factor. Now I've already got minus 1, so I could try 1, I could try 2 or minus 2. Or I could try any multiple of 2 times 2 is 4, any factor. Now I'm going to try, I've already done this to be fair with you, and I got it on 1. But you just keep trying numbers till it works. If you can't do it, I've got 2, 5, 1 and minus 2. And I know that minus 2 is does work. So I get 2, 2 2s is 4, 5 minus 4 is 1, that's minus 2, plus 1 is minus 1, that's 2, that's 0. So again, remainder 0. That means that x minus plus 2 is a factor, because I put in minus 2. So then we can continue to factorise. X minus 1, x plus 2, and 2x squared plus x minus 1. So just check if that's factorisable. You can either see it or you can just check it in some other way. But I can see it as factorisable. 2x and x. 2 ones is 2, and then 1. So I want plus 2 minus 1. 2x squared plus 2x minus 1x is x. Minus 1 times 1 is 1 minus 1, so we're done there. SQA Higher Maths 2024, paper 1, question 11. Express cos x plus root 3 sin x in the form k cos x minus a. And then we'll have to sketch a graph. Okay, let's start. So for part A, we've got cos x plus root 3 sin x equals k cos x cos a minus, so it becomes plus k sin x sin a. I mean, on the degrees signs, you can put them in if you want. So when we compare coefficients, in front of cos x, we've got k cos a. So k cos a equals 1. And in front of sin x, we've got k sin. And in front of sin x, we've got k sin a. So k sin a equals root 3. So to get our k, it's the square root of 1 squared plus root 3 squared. That's the square root of 1 plus 3 is 4, which is 2. Then we can say that tan A is sine over cos, root 3. So then we do the inverse tan of root 3. Well, that's an exact value. 60, 30, 2, 1, root 3. That's 60 degrees. And now we need to check, is it that one? So cast diagram. Sine was positive and cos was positive, so it is 60. So our final answer is 2 cos x minus 60 degrees. And we're done there. So usually a cos graph, just to give you this idea, up here goes to 1 and minus 1, but this one goes to 2 and minus 2. And it's shifted to the right by 60. So if we're shifting to the right by 60, its starting position here is 60 degrees. And then usually here we're at 90. So we do 90 plus 60 is 150. And then usually here we are at 180. So we do 180 plus 60 is 240. And then usually when we come back up, we are at 270. So we do 270 plus 60, which is 330. And we'll just show 360 here. So we're starting here and we're just going down there, along and up. And then we won't kind of get there, it'll kind of all starting. And this one you can see we're going there. Now you might be asking yourself, well, what about this point here? Could we work that out? Well, you actually can quite easily. The answer is 1. And the reason, I'm just going to put some of my numbers in, 60 degrees 2. And the turning point here is 240 degrees and minus 2. So to work that out is when x equals 0. So you've got 2 cos minus 60. Well, if you add 360, don't have to get back into a standard place, that's 300. So we want to know the cos of 300. Well, that's related to an exact value. Cast diagram, 300's here. So that means it's 60. So I just want a cos of 60. Well, the cos of 60 using that triangle up here is a half. So it's 2 times a half, which is 1. So that's why I can put 1 on there quite easily. So I've done that just to be on the safe side. But basically, there's your graph, and we're done there. SQA Higher Maths 2024, paper 1, question 12. A function f is given by f of x is 12 cube root of x. X is greater than 0. And it says when x equals a, the rate of change of f with respect to x is 1. Rate of change differentiation. Find the value of a. So let's differentiate it. So let's differentiate it to find the rate of change. So I'm going to need f of x in a differentiable form. So I'm going to say 12x to the cube root of x. Cube root is a third. So that means I've got a third times 12x. Take away 1 to the power, minus 2 thirds. A third of 12 is 4. So I get 4x to the minus 2 thirds when we differentiate. And it says when f of a, when x equals a, the rate of change with respect to x is 1. So when x equals a, so f dash a, f a minus 2 thirds equals 1. So we need to solve this equation. So there's lots of ways you could do this, but I'm going to actually just put it back into 4 over a to the 2 thirds equals 1. So that means that a to the 2 thirds equals 4. So what is a to the 2 thirds? That's the cube root of a squared equals 4. So if I just cube both sides, that'll give me a squared. And 4 fours is 16 times 4 is 64. And the square root of 64 is 8. And x is greater than 0, so it is just 8. And we're done there. SQA Higher Maths 2024, paper 1, question 13. P and Q are the points 4, 10, 6, 2. And find the equation of the perpendicular bisector of PQ. So there's PQ there. Perpendicular bisector means it cuts it in half at right angles, as you can see. So I need the midpoint. So for part A, I need the mid of PQ. Well, that is 4 plus 6 over 2 and 10 plus 2 over 2. 4 plus 6 is 10, divided by 2 is 5, and 10 plus 2 is 12, divided by 2 is 6. So I've got my midpoint. And now I need the gradient. Well, it's perpendicular, so I can find the gradient of PQ and use m1 times m2 is minus 1. So y2 minus y1, so it's 2 take away 10, all over 6 take away 4. 2 take away 10 is minus 8, 6 take away 4 is 2, so that gives me minus 4. So that means the gradient of the perpendicular equals 1/4, and I need to say why I know that. M1, M2 equals -1. So now I can do my equation. Y minus B, that's 6, 1/4, x minus 5. Take the 4 up to the other side and get x minus 5 on this side. So that's got 4y minus 24 is x minus 5. Leave it in any form you want, but I'm going to do 4y minus x and just take a 5 over. Minus 24 plus 5 is minus 19, and that'll equal 0. And that'll be fine for that one. R has coordinates 12, 2. The circle passes through the points P, Q, R, and QR is a horizontal chord. It's horizontal. So if you imagine this is also a chord, and this is the diameter of the circle. Should be obvious that's the diameter because it's cutting a chord in right angles and at half. So that is definitely the diameter. So there's our centre of our circle there. Let's call that C. Now if I was to drop that down at right angles and cutting that in half, that means that I would have the x part of the coordinate, and I can just sub in my equation and get the y part to get the centre. So that's what I'm going to do. The mid of QR. So part B, the mid of QR is equal to, we've got 6, 2 and 12, 2. So 6 plus 12 divided by 2 and 2 plus 2 divided by 2. 6 plus 12 is 18, divided by 2 is 9, so we get 9, 2. So when x equals 9, that's going to be for our centre, we get 4y minus x, which is 9 minus 19 equals 0. So 4y minus 28 must equal 0. So y is 28, no 4y is, stupid. So that means y is 28 divided by 4, which is 7. So we now know our centre is equal to 9 and 7. Now what about our radius? Well, there's 9, 7 there. Just use a point on the outside. Let's just use this one to get our radius. So the radius is 410 to 97, the distance. So for our radius, which I'll just do squared, I'm going to use 410 and I'm going to use the centre 9, 7. So distance between 9 and 4, so 9 minus 4 squared. And the distance between 7 and 10, 7 minus 10 squared, or 10 minus 7. I'm just going to do it squared because I'm going to use keep it as r squared anyway. 9 minus 4 is 5 squared. 7 minus 10 is minus 3 squared. So r squared is 25 plus 9, which is 34. So that means now we've got our radius squared and our centre was 9, 7. So the equation of the circle is x minus 9 squared plus y minus 7 squared equals 34. And we're done there. It's been Clear Maths today. We've done SQA Higher Maths 2024 Paper 1, the full solutions. Hopefully you found that useful and helpful. The next video is on your screen right now. SQA Higher Maths 2024 Paper 2. Let's go.